Welcome to Khan D Academy. As a compassionate educator, I feel the obligation to run a real-life solution to this extremely difficult AP Physics C Mechanics free response question, which was one of the hardest questions that has showed up in AP Physics C exam history, which only 1% of the students got it right. And here goes the problem. You are to perform an experiment investigating the conservation of mechanical energy involving a transformation from initial gravitational potential energy to translational kinetic energy. And as you can see, there are 5 sections of this problem that we need to solve. A. You're given the equipment listed below, all the supports required to hold the equipment, and the lab table. On the list below, indicate each piece of equipment you would use by checking the line next to each item. So, I have decided to use a track, a cart, no string, a meter stick, no electronic balance, a stopwatch, maybe a set of, no set of projects of different masses, and no lightweight, low-frequency pulley. And here is how we will run the lab. So for part A of the problem, we decided to use a block, a cart with pretty much frictionless wheels on a frictionless track. And we used this physics book to lift up one side of the track to provide this cart some gravitational potential energy. The way we're going to run it is just release it, and at the end we're going to stop it. This way, this is the situation we're going to create, that the gravitational potential energy transforms to kinematic energy. Also, we're going to use this sensor to provide us the data of the velocity of this cart through this traveling process. The laptop will give us the velocity and the position change through the sensor. And that way we'll figure out the velocity so we can calculate out the kinetic energy at the end.
Okay, so for part B, outline a procedure for performing the experiment. Include a diagram of your experimental setup. Label the equipment in your diagram. Also include a description of the measurements you would make and the symbol for each measurement. Okay, so our lab setup would look like an inclined with a cart on the top in the beginning, and because we want to prove that potential energy mgh equals half mv squared, we would need the vertical height of this incline, h, and this will be measured by the meter stick. And also for the velocity, we would have to know how fast the cart goes from the beginning of the incline to the end. So we'll have to know this distance, d, and we'll be measuring the time from start to stop with the stopwatch. The time will be written as t. Yeah, I'll just make sure and label these cart, then track. Okay, now for part C, give a detailed account of the calculations of gravitational potential energy and translational kinetic energy both before and after the transformation in terms of the quantities measured in part B. So for question C, we're first going to start off with potential energy equals mgh, which is mass of cart times gravitational acceleration times vertical height of the incline. And in the beginning, kinetic energy is going to be 0 because it's not moving. Yeah, and at the end, potential energy is going to be 0 because it comes down all the way, and kinetic energy will be half mv squared. Now, g is a fundamental constant, and h is expressed in the diagram mentioned in part B to prove that the potential energy turns into kinetic energy. We have to set up an equation mgh equals half mv squared. And now the m's go away, and then it's 2gh equals v squared. However, this v squared is v final at the end when the cart arrives at the bottom of the incline. So, but what we would measure is v average, which is distance d over time t. But because we know that the velocity change of the cart over time is linear, since the acceleration is a constant, we can assume that v average is half of v final. Because it's a linear function, this area would equal this area if the y value for this blue rectangle is v average, and therefore we substitute vf with so vf equals 2 v average, and now we substitute 2 v average instead of v final. So now we get 2gh equals 4 v average squared. And then if we reorganize it, it's going to be v equals root half gh.
This guy says,
Hi, this is GP, and if in the system, if there's an energy increase in the system, there should be some. It means that the energy conservation isn't working, which means that mgh is not equal to 1/2 mv squared, and the energy is increased, which means that kinetic energy is larger than the potential energy. And the only difference between the two equations, the kinetic and the potential energy, is the velocity. And then if the energy is increased, it means that velocity is increased. And then velocity can be increased when there is initial velocity added. So we assume that there is an initial push push on the cart. And then in the case that the energy is decreased in the system, there should be some kind of force against the cart, and it could be the friction force. And then friction force is not conserved, so it's not conserved, and then it can decrease the velocity of the cart, and then eventually it can decrease the energy of the system.